I don't care. All right, so we've done this is our third presentation now on ES6 or ES7 or ES6, and it's a topic that keeps coming up. People want to know more and more about. So if it feels like we've done this too many times, we're sorry, but it is something that we get a lot of questions about and a lot of interest in. So this time we try to take it from a little bit different approach where we show a before and after on a feature by feature basis. So what your code would look like before ES6 or ES7 and what it would look like afterwards. There are a bunch of links throughout this presentation to JS bins that you can play around with. So if you want to follow along, the link at the bottom will take you to the slides. And as you go through the slides, there'll be links to JS bins or just places where you can kind of get your hands dirty and see the code. So that's the slides link on the bottom. I also put it in the Slack channel. So unless anyone objects, I'm going to move on and you won't see this link anymore. Also, yes, if you want, the before and afters are on different slides. So if you want to compare before and afters, it'd be good to have the slides open just so you can see the two. It was too busy to get them both on the same slide, so sorry, kind of. So ES6, what is ES6? ES7, ES 2015, ES 2016, ES Next. These are all kind of synonyms for the same idea. So ECMAScript is the specification behind JavaScript. There's a standards body that creates this. There are other things built off of this specification, but JavaScript is obviously the biggest one. So here are the different versions of ECMAScript throughout the years. The first one was in 1997, and then number 7, also known as 2016, is being worked on today. So as you can see, between 3 and the next version, there were 10 years before any features were added to the language whatsoever. So it's kind of, this is all these changes that are fast and happening at a faster iteration. This is new, but it's going to keep happening year after year. The plan is to have a release every single year where new features will get added to the language. So if you hear ES6, it's a synonym with ES 2015. It's just the year it came out. So you're going to hear ES6 or ES 2015, ES7, ES 2016. All they're referring to is the version of the specification and the year they came out now. And then again, every year a new set of features are going to be added to the language. Any questions about that? So how are features added? How do you know when they're added? How do you know what they are? How do you know what's coming? This is the technical committee, TC39. It includes people from industry leaders and companies that work on the web, as well as individuals. You can learn all about them down below. It's boring. This is the good parts out of all that you'd go through, essentially. This is the process to when a feature gets added to the spec. So you start off with the stage 0 where you basically community people and leaders are discussing maybe a problem or something that would be nice to have. They gather input from the community, and many things don't ever make it out of stage 0. But there are a handful of stage 0 things there. If something makes it past there, it goes through this set of stages 1 through 4. And really, when something becomes a 2, it's got a pretty good chance of making it the rest of the way, because that's when they've created a formal spec and some syntax. And this is important to know because as you're transpiling code, part of this process to get something through here, if it's possible, is to create polyfills so that things can start being used today. And so if there's a stage 2 feature you want to add, you can also add like Babel plugins that will transpile all the things in that stage or that particular feature. So if you see something coming up that you want to use, if stage 2 and on, you're going to be a little safer. I wouldn't probably go anything lower than that. But if you wanted to use something that's coming in the language, you would just you would pop in that plugin into your Babel config, and it would allow you to start using those features. So any questions, comments? If you want to learn more, this is a very broad overview of those steps. If you want to learn more, again, the link at the bottom of the slide will tell you more than you want to know about this process. So here's where we kind of get it. We're going to get our hands dirty a little bit and just kind of look at some before and afters. I can't cover every single feature that there is, but here are the things that you'll probably run into the most. These are the most commonly used, or the things that are very helpful. And so I'll kind of go through what they are, what they provide. Let and const. Who knows what those do, what those are? Raise hands, anyone? A few of you. Okay. So this is in a replacement, or it can live side by side, but generally it'll be a replacement for just var variable name equals whatever. You would replace var with let or const. And the benefit it gives you is block scoping and single assignment. We'll go through what that means, okay? So here's before using let and const, right? Anyone know what kind of scoping ES5 is? When you have a variable, what does it scope to? Anyone know? Functions, yep, it's function scoped. So in this particular demo code here, who would tell me what would happen? Anyone want to walk through that and let me know what the result of this code would be?
I would not be found because it's only within the for scope.
Okay.
You smile at it, that's not right.
That's not right.
Look at line 1.
So line 1, it's declared, this is basically, now there's an implicit function scope here, right? Whether this is a module or a file or the window or just, whatever the case may be, there's kind of this implicit scope.
Yeah, so I is reassigned on line 3 and incremented
Okay.
as it progresses through the loop. So for now, someone dial 2.
Okay.
Doesn't it puke on the re-declaration?
Oh. No, it might on the reassignment.
So log 0, 1, 2, someone dial 3.
Oh my gosh.
Was that expected? Yeah, sorry. Is that good? Good? So it says someone dial 3, right? And right, the reason why is this entire code here shares the same function scope. So we modified I within a for loop. It's not limited to there, right? All right, so
I think 3 then instead of 2.
the
It must be a post decrement.
yeah, the post increment.
Oh,
Yeah, and then jump out at I.
gotcha. I understand that.
So here's what it would look like after when we're talking about the block scoping feature of const and let, right? So this exact same code, all we did was we replaced var with let, right? That's the only difference between these two. Oops. Oops, there it was. Okay. It's the same thing within the block for the for loop. I has its own private variable scope, right? And then down here, even though we declared this up here, we re-declared it here. This isn't aware of the block scope within the for loop, just by using let or const. Does that make sense? You good? All right. So that's let. We haven't talked about const, right? So const, we have this idea of single assignment. It's not really a constant in another language sense, but it's single assignment, okay? And so looking at this code, anyone want to guess what happens? So if we go through, we're declaring a bunch of variables, int, string, array, object, and then down below we say, okay, now int's going to equal 2. When we do console.log, what should be there? 2, right? We change the string, same thing. The string would be what there when we console.log that out, right? And as we go on, you would expect the same idea. When you push 5 to the end of the array, and then you log it out, what's that going to look like? Right? And then not only just mutating the array, but reassigning the array right here. And we log it out. What's that going to look like? Yeah. And then same with the object mutation. We're adding a new key, 3 equals 3. We log it out here. What's that going to look like? Yeah, so it's all, there's no trick questions here. Same thing, this lets you just mutate the object as you go along, right? So here's using const when we talk about single assignments. We're doing the same thing. It's the exact same code, but we've removed all the vars with const. So what do you think happens when we try to run this? Yeah, it won't even compile, like it won't run. These are errors, it can't even compile. So if we go to look to see how that is, we actually have to, we'd have to fix it. You see down here at the bottom, saying, hey, int's read only. Like this is a language, this is a syntax error. Like it won't compile, it won't run, right? So what we actually have to do is we can't do that. Same with here, right? So
You
even
said it was single assignment, so if you remove int equals 1 up top of the equals 1, which can you assign it later?
if I do this, you mean?
Yes.
Question. I don't believe you can. Yeah, I think that's invalid. Same with the string. So as we go through, we have to, we clearly, once we've declared a variable assigned with const, we can't reassign it, right? So we can't reassign the integer value here, the string value here, right? Here's another reassignment, we can't do that. And then we can't do that, right? But we can mutate the original array. So we can push new values onto an array, and we can also push new keys or even change keys on objects. We just can't reassign the variable name. So it's not a constant, meaning these are final frozen values. It just means that we can't reassign the variable name. Does that make sense, the distinction?
So you can increment int then.
So you want to see what happened? Let's see. Yeah, it's
Remove keys off objects.
that's a good question. Let's see. I would imagine so, but yep. So if you think it was just the variable is a place in memory, right? So you can't change the memory address of something. If it's an object or an array or something to that effect, you can mutate what that pointer points to, right? So that the other values in the array, the object property, those type of things. So if you want true immutability, you have to use other parts of JavaScript, like object.freeze or a library.
Do those still get garbage collected outside of
And the same type of rules, yeah, when the same type of rules as anything else, yeah. That's a good question. He asked if those are garbage collected. So they are just, it has no effect on garbage collection in that way.
Just like with objects, can you mutate values within the array too?
Yeah, because those are just pointers, right?
What was the question?
He asked if you can change the values within an array. We good? Moving on? Yes, no? Okay. So here's one of my favorites, template strings. What this allows you to do is create multi-line and interpolated variables in a much cleaner way than before. So here's what things look like before if you wanted to create a multi-line string with line breaks and with variables in there somewhere, right? You have to, this is a little contrived, right? But you have a couple of variables somewhere. You want to print out or create this string. And the string is, hello, my name is whatever the variable name is, a new line, and I like to make whatever he likes to make, right? And so this is how you did it before. You actually had to use you'd have to use this. You can't line break within a string. That would break it. So you actually have to use the -n, string together a bunch of concatenation of strings and variables. this is what that looks like afterwards. You have the same, almost the same exact code, except for now strings can be declared with this tick on both ends. Not a single quote, it's a tick, back tick. And then when you want to have a variable within there, not just a variable, really, this could be a function call. This could be anything within there. You would just wrap it around this dollar curly's syntax.
And your line break?
Line break is just there because I put it here, right? So there's a natural line break between here and there. So no.
What about tabs?
I don't know. That's a good question. I wonder if you can. I think it will. Yeah, same thing. It's like pre in HTML, right? So the pre tags. It'll just basically be what you put in there. So the formatting of strings can get a little funky when you're doing multi-line, and within here, like if you notice, indentation matters. So sometimes when you're creating these strings, your code may look a little funnier than, because your indentation will, if you have an indentation within your template string, it's going to be in there within your output string. Yeah. I think you can escape line breaks, and I imagine you can escape tabs. I'm not sure, but yeah, a backslash escapes. He asked if you can escape those like line breaks and tabs. I saw a hand over here somewhere. Huh?
So you can pass in anything, let, var, const, any of those?
Yeah, this could be anything within there that is something that is a pointer to something. It could be a function, it could be a property of an object, it could be really any sort of JavaScripty thing that evaluates out, in this case, to a string.
Can you do expressions?
Well, you can do, yes, like
You basically turn this into a templating language by doing expressions, or do they have to be like data types?
so you can do this or that kind of thing. Mhm. So if we run that, and then if we comment this out, which is easy asking, now it's going to say, hey, I'm going to look for a name. If it's there, I'm going to use it. If it's not there, I'm going to have it be Jared instead. Hey, it didn't work. Or not.
Close enough.
I thought you could.
What if you name from your
Yeah. I'll have to look at that. I swear you can JSBin output. I think we're probably just dealing with JSBin here. But yes, you can.
These that in the project console. Name it something different.
Do you want us to call you right now?
What's that? I didn't hear you.
That's your new name?
Yes. The cool thing is you can also nest these. Like within here, you can kind of create. If this requires you to print out a string or construct a string, you can actually have more ticks in here. Do that as well. It kind of gets harder to read when you do that, but if the need comes up, just know it's there. Any more questions about this? Nope. Okay. Arrow functions. Who has used these or know what they are? Cool. I got more hands there than when I asked if they knew what ES was, I think. So, just for the record. So, a couple of the main benefits of arrow functions is just the compact, lambda-friendly syntax. Who can tell me what a lambda is? Jasper.
Oh, I can.
Who would be willing to tell me what it is? Not Jasper. So typically a lambda refers to a function you pass into another function as its argument. They're typically anonymous. They're stateless typically as well. But usually that refers to anonymous function you pass in as or return from a function as well. But passed into a function as one of its arguments. Okay. And then who understands this in JavaScript? If you raise your hand, I think you're lying. Sorry.
This with the tick?
Just how this in JavaScript works. That is in this case. I'm mixing JavaScript with Markdown here. Sorry. All right, so let's just look at this function before using arrow functions, right? So here we're taking an array of things and we're chaining together a bunch of maps and filters and then a reduce at the end. So who wants to explain, just, you don't have to go line by line, but what's going on? Like, everyone understand what map does? Anyone not understand what map does?
Not too sure.
Okay, so map, if you have, it's a method off the array prototype. So every array has this ability to map. And what it does, if you pass in a function to it, it's going to go through each item in the array, and it's going to apply that function to those, each value in that array. And the thing coming out will be that. So in this particular case, right, we have this function that accepts n and returns n times n. So as it loops through, 0 will become 0. This will become 1, but 2 will be 4, and 3 will be 9. So the new array coming out of that will reflect those mapped values. So you're taking each value within the array and you're mapping it, right, to something else. Filter is similar, except for it you pass in a function, you return a Boolean. True means it's going to be kept in that array, and false means it won't make the cut. So it's how you limit the results of an array. And then reduce is the trickier one. The syntax is funky but super powerful. I would definitely recommend getting super familiar with that because you can do amazing things with it. But what it allows you to do is take an array of anything and convert it, reduce it to anything. I mean, it could be a string, another array, an object, whatever the case may be. But it lets you really, really succinctly and powerfully reconstruct some sort of value or object or array or whatever from a set of things coming in. So the thing that typically people use as examples is to take an array of things and create a sum. This is what I'm doing here at the bottom. Is I'm basically saying, hey, go through all these things, and what we're going to do is we're just going to add them all up. So the end result would be a single number. Right? Does that make sense? If you want to see that in action, you can click on that link. That's the ES5 version. So anyway, something that stood out to me about this slide was how many times the word, function is in there. And the return statements, it's monopolizing really this code right here. It's kind of extra. So using arrow functions, we can create that exact same thing. And it would look like this. So no function, keyword, no return values. Return values are optional, depending on what you're returning. Yeah, return statements, sorry. But this is that exact same code, the same functionality anyway. And hopefully we don't get JSBin output here. Let's see.
I confirmed that the JSBin output in your or expression was just a
JSBin thing.
It works fine.
JSBin's not playing nice today. Anyway, there you have it. It went through that array. It went through that array of integers. It squared it. It divided it by 2. It removed anything in there that wasn't an even number. And then it added all of them up. So that's what that block of code did. But the point being is that the arrow functions there make that set of operations nice and simple and not as noisy as before.
What is 60?
60 is the result of all of these squared, then divided by 2, each of them individually. So let me start over. Each of these values gets squared. Then each of those values get divided by 2. Then we remove anything from that array that isn't an even number. Right here. Well, then it's not the original array though. It's the result of the previous action, right? And then it adds them all up. So 40 is the result of that set of operation there.
60.
Whatever. 60. Numbers.
If you want to get crazy and combine the squaring and the dividing by 2, you just squiggly the.
So if you want, yeah, these. So the format here. This is the simplest form. But yeah, you could do return n times n if we wanted to do it this way. And don't make me a liar. Thank you. But yeah. And so really, I mean, you can, this is the simplest form, but you can, as you see down here, you can have multiple arguments. When you have multiple arguments, you have to surround the arguments with parentheses. When you have 0 arguments, you have to surround it by parentheses. When you have 1 argument, you don't. Some people have different styles. They always like to include the parentheses. You don't. Some people, like, you can optionally, if we undo. We can take this, if we were to take this and add these, then we would have to add a return statement. You can do that. So if we wanted to do some more, you know, let n equal 1 instead, and then return that, that would basically affect that whole output, right? But you can work in these blocks the same way you do a normal function if you want to, but it does get to a point where maybe you shouldn't be using arrow functions. I mean, it depends on what you're doing, but they play really nice in this lambda style of things where map, filter, and reduce, they expect a function. Those functions are typically not super reusable across things. They can be, but typically not. So you don't need to assign them a name. You just say, hey, I'm just going to use this once. It's just squaring, right? I guess you can create a squaring library if you wanted to and import it, but.
Jared?
Yep.
Just to get the terminology right,
Mhm.
when I think of lambda, I think of the arrow thing going on, right?
Mm-hmm.
I think you're saying lambda means sending functions on into functions.
Lambda describes a particular type of function. Yeah.
Okay, so this you call it an arrow function,
These are arrow functions in JavaScript, yep.
which is like shorthand.
It's like lambda, they're like lambda functions plus a little bit more.
So there are lambdas going on.
Yeah.
Oh yeah, there's lambdas, sure, but what I'm saying, this is shorthand for saying function.
Yeah, I think
Well,
the definite, go ahead.
well, there are differences though. You know, if you just take all your functions and convert them to syntax, things will probably break because like variable assignments and scope work differently inside arrow functions than they do inside.
That's the lexical this part that we're going to talk about.
Other than function functions.
Okay, I'm
Yeah.
glad I asked the question, because
Yeah.
otherwise I'm thinking lambda means arrow.
So lambda, I think like the definition of the lambda, at least I'm going to butcher it, but here's a good one, right? It's basically when you pass in an anonymous function, it's an anonymous function that you typically use to pass in as arguments to another function. It could also be functions returned from a function, but just that's getting like way too detailed. Just they're anonymous functions that you're typically going to use as values that you're passing around. Does that make sense?
Makes better sense. That
Okay.
clears it up for me.
Good question.
And they're called lambda expressions or lambda functions?
You can hear both, but typically lambda functions, yeah.
So your example before ES6 with the function and the return, is that also a lambda function? Because
Yeah.
it has a variable.
Yeah.
What was that question?
He asked if before, if those would they're technically lambdas because I don't think they had variable names and they were anonymous. So yeah, these are getting into like the real technical definition. You're probably going to get in arguments with different types of people based on this. But the idea generally is they're not like library functions that I mean, they can be. They're functions you pass around. How about that?
The point is JavaScript has always supported lambdas, but with the arrow functions, it's adding syntactic sugar
Exactly.
on that lambda expression.
Yep. Yep. Okay. And then the other part, let's talk about lexical this. So this in JavaScript generally is best avoided if you can. Just avoid it and save yourself bugs, seriously. Sometimes you can't. I mean, that's just how it goes. All right. So in other languages, this behaves very predictably, in statically typed languages particularly. In JavaScript, this depends on how your function is called, is what this refers to. This could, if you said something is a new this, it refers to one thing, or if you don't do the new before that, it refers to something else. This could be the function, it could be it just varies depending on how you call it. Okay? So this is kind of more complex, but here are some things that you should see sometimes, that you may come across in code sometimes.
So I've heard it described as this is the thing before the period. Is that accurate?
No. Yeah, it varies. So depending on the context, right? So who has seen this pattern before? Var that equals this, or var self equals this, or var whatever equals this. Why do people do that? Who wants to? Huh?
It's to save the context.
So to save the context, because the context changes, right? And that, this changes, so it's hard to figure out what it is. And so if you need to retain a particular context, you have to create a pointer to it, essentially. And that's what var that equals this does. Because right here, this refers to this object right here, right? But down in here, if I were to put a this, what would that refer to? The function in there, right? And so we have to do this kind of this weird acrobatic thing where we're saying var that equals this. That's one way of doing it, right? The other thing that you're going to possibly see is people using bind. So functions have this method bind off its prototype that lets you specify what this should refer to, right? So in here, I didn't have to do the var that equals this stuff and then that, right? Talking about this and that is really, I don't know, it's really difficult. Anyway, same thing down here. I'm saying this is what your this should be when I use that bind syntax. So anytime that this, the keyword this, is used within this function here, it's going to be bound to this. Crystal clear, right? All right. Any questions about that?
Is that stack, so stack 2 is the ES6?
So no, both of these are ES5.
Both of them are ES6.
Yeah. And so actually one of them is probably ES before 5 and one's ES5. So I think the latter one is ES5. I'm not super great on trivia, but I believe that's the case. Either way, we can see what it's doing is we have this object with friends and a trader, and this function that when you call it, it goes through that array of friends and it removes anyone that's a trader, right? And then this is what you get in the output.
And these names are totally arbitrary.
Yeah, I just made up these. These are very meaningless names. Yeah, that one. All right. So let's call this, right? This is one of the other kind of perks of arrow functions. It doesn't adjust what the context refers to. So down in here, I won't go to the demo, but it works exactly the same way, hopefully. But down here, you see there's no var that equals this. There's no bind. Because I'm using this arrow function right here, this does not change. So this refers to whatever this referred to outside of that. Clear? Good. So inside an arrow function, this refers to whatever this referred to outside the arrow function. Yes?
Yes.
No? Anyone? Yeah. So it doesn't change this, okay? It just, whatever this was before, that's what it's talking about. Just don't use this and seriously save yourself a headache.
So that's why you probably couldn't use an arrow function for friends, not traders, because then it would refer to this outside of the stack.
That's a good question. I don't know what that would do. The question was if you were to use an arrow function here. So friends, not trader is a thing you want to give the world and see. So running this should produce that same output before. He's asking, what if we do this? Yeah, I don't think it'll work, but you know. No, that's not what I meant to do. Live coding, sorry. This little thing hanging around? Hello? Oh, it already is. Yeah, cannot read friends of undefined. So in this case, this is not defined anything. You could have predicted that, right? So just don't use this. All right. Any more questions about this before moving on? This. All right.
Worse than saying
All right. Enhance object literals. How are we doing on time? I'm going to go a little faster. Okay. Shorthand property assignment. So this is a little contrived, but it's something you're going to come across where you have a bunch of variables that you want to take and then construct into an object where the name of the key is the name of the variable and the name of the value is the value of the variable. Yeah? So down here you have to do this very redundant thing here where you're saying, hey, return this object and make toppings equal toppings and size equal size, and just, very, very redundant set of code right here, right? So this is nice because in ES6 you can do the shorthand property assignment where if you just do this format here, it'll automatically do what I just did before. Where now time would be one of the property names, and the value of 60 times 30 would be its value.
Real quick, I noticed on all the var or ES5s, you did the syntax where you say var toppings and comma. Is that possible in Const and let, or is there?
You can, but I'm used to 4-character indentation, right? And so when you do that, it lines up nice and perfectly with var.
Okay.
With Const, not so much. So, good question though. So generally, really var in ES6 and beyond, I can't think of why you don't want to use it. So if you need to mutate the value, you use let. If you don't, use const. So, which ruins all my tabs. Okay. So again, before when you want to construct a method off of like an object literal, right? You'd say, okay, let's have onClick, it's equal to a function here. That makes sense to everybody what we're doing here? Not make sense to anyone? So you can use this shorthand in ES6 where you just do, hey, onClick is use this format. These two things do exactly the same thing. With me?
The variable syntax you had before, can you use that for functions as well?
I'm sorry?
Where you're showing the previous slide.
This one?
Yeah.
Yep.
those variables can use for functions.
Yeah, the values could be anything you want them to be. So yeah, it could be anything in there. The question was, does this work for any value that a variable points to? And yes. So enhance, this is what you do after. Questions about this? I'll go a little faster, I'm running out of time. Computed property names, who's done this code? We need to have the property be based on a variable. Yeah? So property is based on a variable, like in this case name, and then we have this object, but we want to construct a property name that's Jared from a variable that maybe we don't know what that value actually is at the time we run this. So to get around this in ES5 and before, you have to create a new object, and then you'd have to do the syntax down here where you're saying, hey, object variable property name equals this. So in the output here, it would look like, object.jared equals Anderson, right? We good? Moving on? Okay. In ES6, you can have computed property names. So this is the exact same thing as before. So if you have this variable floating around, in this case name, and you want to add that as a property name, you just follow the syntax here. So this could be this is computed. So it's more than just variables. It could be the result of a function call. It could be anything that evaluates to something that will become property name friendly.
By computed, you mean dynamic?
So you could put, I could replace name here with math.random. And then I'd have, I'd be interested in that. I'd probably break, because, well, no, that'd probably work. But you could.
Math.random is a function.
Well, math.random executed. So the result of that, whatever that evaluates to.
So any like a number,
It's
just
If as long as it's a valid property key, which I think JavaScript's pretty nice about that, it'll even work when you don't want it to. So, questions about that? Okay. Here's a demo of kind of each of those things. I'm just going to kind of go through it real quick. But so here you can see we have this variable definition A, B, C. Here's what it looks like in ES5. In ES6, this is this is what the ES5 version would look like if we had to do the same type of thing. This is an example of using that math.floor, math.random to evaluate that.
Jared, can you, in ES6, can you mix it? So if you say A, B, C, comma, Jared, colon, Anderson.
I don't understand the question. Can you?
I think that you can.
What was the question? I don't.
He wants to know if you can mix the new object level syntax with the old one. So some of your things are well defined. Because I know that you do that in React all the time.
Yeah.
So I would assume.
So what was the question?
So ES6, I don't know, but whatever he said. So ES6 is ES5. You can do anything you did in ES5 and ES6.
But I asked if you could mix it in the same.
Like in an object, when you're constructing an object, yes.
Okay.
Yeah.
Good question. Thank you.
Great question. Thanks. I'll let you play around with that one. That basically takes all those characteristics we talked about in one demo, and so you kind of see how that works. But if you have questions, then hit us up on Slack or in person. All right, destructuring. Okay, this allows you to have some constructed object or an array, typically, of things, and you just want to pluck out like values from within that. Okay. So before ES6. If you wanted, here's an array of 0, 1, 2, and 3. If you only wanted 1 and 3, this is how you get to them, right? You just say, hey, I want 1 to equal R1, 3 equal R3. Pretty self-explanatory. Good? Okay. Destruction array in ES6 could look like this, where you can actually, this has that exact same effect, where we don't have any reference to 0, we don't have any reference to 2, but we have a reference to 1 and 3 based on placeholders, skipping 0 and 2. And now the values of 1 and 3 are what you would expect them to be, the string versions of 1 and 3.
Do spaces matter?
No, not here. But if you want to let other people read your code, you can do. Yeah.
So this is an anonymous constant array?
Nope. So 1 and 3 are now are
The only ones there.
Yep.
So it's kind of like a filter.
So I could do console.log 1, and I would get the string value of 1.
No, he's created 2 new constant variables, 1 and 3, off of array based on the position they are in the previous array.
Okay. That makes
Do they
sense.
need to be constants?
No, I could use var here.
And so if they were vars and you modified them, would it modify the array?
No.
So it's just one way to be able to break out small bits of variables and separate them.
Yeah. So if you need to, I like the word pluck. I need to pluck this and this and this. I don't need everything. I just need certain parts of the thing, and I want a friendlier syntax to get to those instead of having to, throughout your code, either just do this once at the top or do this all over the place. It just makes it a little clearer to read, much more pleasant to write. So Tim, to answer your question, if each of these were in the array was an object and you mutated the values of the object, the values of the object in the array would be mutated as well, based again on the whole idea of memory location versus, right?
Jared, Chris has a question over here.
Chris,
I know the answer, but I just want to hear from you.
are you? All right.
So how do you refer to that variable once it's all done?
1. So this, here, let's just go down here.
Just like
Same as the way you referred to the last one.
Yep. So down here, if I run this,
He's created a new variable called 1.
Yep.
And assigned it to the second position in the original array. Correct. It's a value type, so it's getting a value, a non-value type. pointer.
Yeah, I'm gonna blow your mind here in like 3 slides. I'm sorry. Okay, so yeah, that makes sense to everybody. So on now in this scope, 1 and 3 refer to the values of that position in the array. Yeah, it's clearer than this, isn't it? At least maybe. Okay. How about object destructuring? Same idea. We have this big giant object that maybe in our code we don't need everything in there. We just need a couple of the properties from there. And just to make the rest of our code easier to write and to read, we're going to create these shortcuts here. 1 equals obj.1, 3 equals obj.3, the same type of thing, right? This makes sense to everybody? All right. So destructuring that in ES6 would look like that. Right? So 1 refers to obj.1, right? 3 refers to obj.3, 5 and 7.
Can you give them aliases in that?
Yeah, that's the next slide. You can. So, yep. If you want to rename what they get to, right? What are your variables now available to you on this code? Who wants to guess? Yep. So we're saying, hey, grab 1, give it the variable name uno. Grab 3, give it the variable name tres. So throughout this scope, 1, 3, 5, and 7 refer to object.1 and so on and so forth.
Why did they do it backwards?
That's what everyone always says, and I don't know. Like it took me a while to kind of get my mind around it. I have to think of it like a map. So we're just mapping. We're going to say, hey, map 1 to uno and 3 to trace. But yeah, it feels very backwards. I'm with you. So if you can just mentally picture a map, you're just mapping it to, I don't know why, maybe it.
Learn, don't do it.
All right, well, then you have if that was confusing here, how about this one? So here we have a deeper structured object, right? Object.1.spa equals uno. With me? Object.2.int equals the integer 2. Right? This makes sense to everyone? You good? All right, how about here? What are the variables here?
So the variables are Spanish 1 and number 2.
Uh-huh. Spanish 1 is a variable now in the scope.
One, so that's uno.
So, yep, same thing, the map. We're mapping object.1.spa, right? Object.1.spa, or object.1.spa, which is uno, and we're mapping that to Spanish 1.
It makes sense if you say the word from in front of each of them.
Yep.
From 1, from spa.
So I think there's an initial feeling of disgust when you see this.
Yes.
But as you get used to the syntax, it's very nice in some regard to be able to do that.
So you only feel dirty after using it?
You get used to the dirty.
So the syntax that triggers this behavior is the const curly brace,
Mhm.
and the let curly brace does the same thing.
Yep, our var would do the same thing too. Questions, comments?
Looks worse.
Looks worse. It feels that way at first, but the thing is, it's so different. It feels so backwards and different that it doesn't immediately register what it's doing.
So
Once it starts immediately registering what it's doing, it becomes just you look at that and it makes sense without you even thinking about it. It gets to a point where it's that.
Saved yourself in the upper typing.
And it depends on what all these little things are like little tiny cuts, little things. You combine all of them into an app. I mean, you can have a serious reduction in your code base
so you may
if you're not used to it.
You may not have to use you don't have to use these features,
Yeah.
but you need to know them because you're going to come across them.
Right. And they get to a point where you reckon this you don't even have to think about. Like right now you're having to think about it, but it will get to a point where you don't, and then it doesn't feel so dirty.
So really, you use this on an often enough basis that when you
Yep.
apply.
Yep. So how about destructuring in declarative function arguments, right? So if we were to look simply at just the signature of the function, it's not clear what's going on, right? You have to go through and you have to read the body of the function and say, hey, Okay, error is an object. Error needs to have these properties: recipient, severity, message, and details, right? So to kind of get a gist of what a function does, you have to read a little further into it. So with destructuring, you could do the same thing. Here's destructuring in template strings, where it's a little clear on what's expected coming in and what it's doing. It's an object coming in, because we're destructuring the thing coming in. And now within our function body, we have these variable names of recipient, severity, message, and details. And so you're going to see this a lot too. Hey, how about we want shortcuts? We want person coming in and mood coming in, right? But we're going to reassign these to shorter variable names because characters. I don't know.
Can you go back one?
Mm-hmm.
So where is the destructuring of error? Because it doesn't even show error.
So it's an anonymously named thing here. So we're saying, hey, destructure the first argument coming in, right? Destructure this. So it's saying, hey, an object's coming in. Destructure that. And what we want from that. So this could be a big, giant, ginormous object of any really shape, size, or form. But on that, it needs to have these 4 properties. And when an object coming in with those 4 properties, it's going to produce that.
So if I call error message, and I can pass in any object, but it has to have those 4 properties.
Correct.
It'll destructure it.
Yep.
Okay, I get it. Sorry.
Hang on, they're going back here.
And so what if it doesn't? Are they undefined? Or?
In this case, yes, but you can, that's coming up maybe over here. Okay, Tim.
Can you name the object so that you still have a reference to the object as well as to the?
Yeah, maybe. I don't know. I'll. Okay. So makes sense here. There are some demos you can play around with. Default arguments. This gets to the question you just asked about here. You can. Who's seen stuff like this where you have things coming in, and right below that we're doing all this stuff to say, hey, well, the effect of this is Will's arg is optional. If you don't pass it in, you get Will's. Round 1 arg is optional. You don't pass it in, you get round. Round 2 arg is optional. You don't pass it in, you get round as well. So now you can call this function with or without arguments, right? Without them, it's going to work. It's going to annoy all the parents with the song. Okay? Same idea here, just a little more explicit. We're saying, hey, we accept Will's round 1 and round 2. If you don't pass those things in, we're just going to do exactly that same code as before. So basically, we're just kind of, this is a very common pattern, the shortcut pattern of, hey, use this or that, use this or that, use this or that. So in ES6, the equivalent version is that. So those two code, those two things do the exact same thing, right? So how about destructuring with defaults? Okay, almost exactly the same code as this before, but instead of expecting 4 arguments, it only expects 1, which is an object. And that object needs to have these properties on them. And if they don't have these, we're going to make them, right? So if you have an object passed in, but you don't have the Will's property in there, we're going to say, okay, well, Will's is going to be Will's, unless you do bus driver or whatever, whatever you want to pass in. Good? Make sense? Kind of? Okay. What if you don't pass anything in? Is this going to work? It's going to die. So this lets you not only determine default property names, but it doesn't tell you what is being passed in. If you want to do both, hey, here's my default property names, and on top of that, if you don't pass anything in, just start with an empty object. So this is that. Now you could call this function without any argument whatsoever. And what that will do is basically, it will allow you to optionally pass in something. If you pass in an object, you can override Will's round 1 and round 2. There's a question over here.
I was wondering, instead of the $sign curly braces, where you're using that inside of the backticks, are you allowed to put any JavaScript in there?
Anything that, function calls, object reference, anything that evaluates to some
Variables and then
expressions. You can't do var. You can't do a body of a function, but you can do expressions like this or that and this and that kind of thing, or ternary, or something that's an expression. If it's an iffy, if you're familiar with iffies, Okay. Questions about that? Does this make sense?
That might be dirty, just but you can recheck on that last question.
You probably wouldn't want to do that, but you could. So the difference between these three, right? This is a function that expects 4 arguments. You have defaults for each of them. If you wanted to bypass one of them, you actually have to pass in undefined. You can't pass in false. You can't pass. It has to be undefined if you want to skip one. Down here, if you want to skip, this is just one argument. It expects you have to pass it in an object. You have to. It could be empty and it'll work, but you have to pass in an object. If it's an empty object, it's just going to use these default settings. And the one down here, you don't have to pass in anything. If you pass in, yeah, you don't have to pass in anything, and it'll work. So basically, it's that same thing before. The key difference here is we're saying, hey, that first argument is an object. Take those properties, assign defaults to them, and on top of that, if they don't pass that in, just make it an empty object. Okay. And so this is a live object, by the way. This could be a reference to a variable somewhere else. Does that make sense? All right, we're almost out of time. I'm going to go really, really fast, and then we're actually out of time, so if you leave, I won't be offended. But I'm going to go really, really, really fast. Okay, spread. Who's seen this? Like, this is very contrived, but there is a point in time where you have an array of values. You got that from somewhere, who knows what. But you need to take each of those values, and you actually need to take them, and you need to use them as arguments in like a three argument function, right? And so here you have to do this apply type of thing, where you're saying this is ES5, where you say, hey, take those array of values and actually apply them as the arguments to that function. So here you're going to add up 25, 50, and 25, right? That's what this does. So spreading over an array, you can do something very similar, but this 3-dot syntax does that exact same thing. Takes an array, spreads them out as arguments. So now you're calling this function with 3 arguments, just like the function expects. So this right here is the context that you would inject in if you wanted to change this. This has that explicit nullish behavior. Okay. Objects, this is a stage 2 feature, I think, or 3. Merging objects in JavaScript, right, is basically what it's good for. So there's a new prototype off of object, a new method off the prototype of object, or off of, actually, it's just a static method off of object that lets you merge objects together. It's a shallow merge, okay? So basically what's happening here is whatever you have as your first argument here is actually going to be mutated, just like in jQuery and underscore, I believe. And anything after that is just kind of get merged over it, right? So most commonly you're going to see people pull in some sort of library to do this. It's actually pretty complex to merge objects when you're dealing with strange types and things like that. So it's not built into the platform because there are a bunch of little gotchas. Or it hasn't been. This is all shallow still, okay? So I imagine most people are familiar with this. Yeah, we've all done that once maybe in our life with jQuery. Same with underscore, but basically all it's doing is merging 1, 2, and 3, 3, 4, and 5, where your final results will have, see right here, there's a little 3 equals 2, and here 3 equals 3. In both this case, the final object would be what you'd want it to be, where 1 equals 1, and 2 is 2, and 3, 3, and so on and so forth, right? Yeah? Okay. Using spread, this is what that looks like. We have 2 objects. We're spreading out them into a bigger object. Both the first and the second creates a new object. Same result as before. This is a really nice feature, especially within maps and reduce and whatnot, right? So this essentially creates a new object with a shallow copy new object. Does that make sense? Okay, REST parameters. It's a contrived example. The gist is we want to create this function. The first argument's a value. Then we have n number of arguments after that. Each of those things are a function. So what we want to do is pipe that first thing and take that and pipe it through a whole bunch of functions, right? This is what we want to create. So down here, does this make sense to everybody? When we call this, we want to take x, put it through F1. The return value of that goes to F2, the return value of that goes to F3, and so on and so forth. So we want to construct that. So how would we do that in ES5? It's kind of gross, right? We have to pop out first value argument 0. Then we have to coerce arguments into an array because it's not an array. Then we want to slice it from the first to the very end. So what that gives you now is an array of functions and that initial value. And here's what that looks like in ES5, which isn't as bad as you would think, but that's what you have to do. I'm going really, really fast. I'm sorry. So what the rest parameter lets you do is this. Lets you wrap up n number of arguments into an array with that same idea where we're saying, hey, that first value coming in, we want access to that, and then we're going to wrap up every other thing coming in into an array. So in this particular case, we have that first argument is a value, and then now we have an array called FNS, functions, right? And that's an array of functions. We do that same thing. This would let you pipeline that first value through all those functions. I'm just going really fast. Okay, last one. Where am I here? Symbols. Who's done this? You need to like identify some unique identifier on something, right? Like a key. You want to make sure that it's not really private, it's unique, right? So you construct these crazy strings that represent only that you shouldn't see in other code, right? So a symbol solves this. You can declare symbol my key twice, and they're two different symbols. So it's not private, but guaranteed uniqueness. Modules, I'm going to go real fast. Typically, we haven't had that in the browser, so we basically clobber the global scope. Then we started using tools like Browserify and CommonJS that allow you to simulate modules, or System.js. These are basically things that let you not clobber the global space. Those all require build kind of stuff, right? ES6 has that built in. It's not currently implemented, so you do need to still have a build setup to do it, but there's a standard way of doing it now. This is what that looks like. Quickly, you have named exports, which in this case are A and is cool. So when you have named exports, you need to grab them this way. Then you can have unnamed or default ones. And when you do it that way, you grab it like this. You say, hey, I'm going to call this what's being exported whatever I want. It doesn't matter. I can name it in my module whatever I want because it's the default export here. You can do named imports. Import A as B if you wanted to. If you already had var or A in your current scope, if you wanted to change that. All right, that's the last example where you can learn more if you want to learn more about these features. So on Babel, Babel's a transpiler. If you're not familiar with it, I get familiar with it. But they have a really good section of all ES6 features with coded examples. So go there. If you want to see what's in the current proposals, you want to see stage 1 through 4. That's a good place to kind of see new features coming up, understand what they're trying to solve, which ones you can use now. If you want to see what works without needing transposization or what can be transpiled, these are some good charts for that. And then just here's a good set of just tutorials and stuff you can go to that would explain more about each of these features. The end. Any questions or anything? No? All right, we're good. Sorry.